Namaste everyone. In this video we shall solve a question from NCERT exemplar. This question is from physics, from a chapter called electricity. This is for class 10. So let's see what is the question and how we can answer or how we can solve that numerical problem. So let me display the question first. Let's understand the question and then we can concentrate on solving it. So the question says, in the following circuits, so there are three circuits which are given. I was unable to copy the three circuits, so I'll just anyways draw the circuits while explaining the solution. So here they want us to know what is the heat produced in the resistor or combination of resistors connected to a 12-volt battery. So in all the three circuits there is a 12-volt battery, and we'll see that in first circuit there is a single resistor. In the remaining two circuits there are two resistors connected, in one in series and another one in parallel. We'll see that. So look at the options. Option A says same in all the cases. What is same in all the cases? Heat produced in the resistor. Is it same in all the cases? We need to answer. In the second case, it is minimum. The heat produced is minimum in case 1 or not, is what we have to tell. And in option C, it is maximum in case 2. And in option D, it says maximum in case 3. So here the subject is the heat produced. We need to compare the heat produced. Before comparing the heat produced, let's calculate the heat produced in each of the circuits. Now, what are the circuits and how to calculate the heat produced in all the circuits is what we will be discussing. So let's see what is the circuit and what is that we need to calculate here. So as you can see, the first case in the first case there is a circuit wherein there is a single resistor. So let's see what is that single resistor. Now the circuit is like this. As you saw, the battery was a 12-volt battery and in the first circuit there is a single resistor having resistance 2 ohms. We need to find out what is the heat produced in this first circuit. So if you recall, there are 4 different formulae to calculate heat produced. I have made a short video on list of important formulae related to electricity. Please look into that short video if possible. I'll try to upload the link of that in the description of this video. So there are 3 formulae, rather 4 formulae, as I said. The first formula is H is equal to VIT. This is the first formula to calculate heat energy. Second formula is H is equal to I square RT. H is equal to I square RT. Now let's look at the remaining formulae as well. So H is equal to VIT, H is equal to I square RT. H is equal to V square by R into T, and H is equal to VQ. So these four formulae can be used to calculate heat energy. But which of these 4 formulas should we use here is the question. Now you can see in the circuit there is the value of V, potential difference, and it is 12 volts. There is the value of resistance, that is 2 ohms. So we need to use that formula of heat where both V and R are present. So from this we can conclude that it is advisable to use H is equal to V square by R into T. We shall use this formula, H is equal to V square by R into T, and calculate the heat produced in the 2 ohm resistor. So now let's see how we can use this h is equal to v square by r into t and then calculate this. Here the value of v is the value of v is 12 volts, so 12 by the value of r, that is 2 into t into t. So let's simplify this. 12 square by 2 into t. So this heat will be equal to 12 square is 144 divided by 2 into t. So this will be equal to 72, 144 by 2 72 t joules. Now what does T represent here? T represents the time for which current flows through the resistor. So it is not given in the question. So for our convenience, let's assume T is equal to 1 second. If I use T is equal to 1 second here, H is equal to 72 into T, that is into 1. So the heat produced will be 72 joules. So what is the heat produced in the first case? The heat produced in the first case in the 2 ohm resistor is 72 joules. So this is joules, the SI unit of any energy. Now we have assumed T is equal to 1 second. So we need to assume T is equal to 1 second in the remaining 2 cases as well, so that the comparison will be a fair one. So now let's see the second circuit and see how to calculate heat produced in the combination of resistors there. So in the second circuit, there are two resistors of 2 ohms each. These two resistors are connected to a 12 volt battery like this. Connected to a 12 volt battery. Please wait. 12 volt battery, yes. Well, now they are interested in the heat produced in the combination of resistors here. So the combination, as you can see, is a series combination, and the equivalent resistance in series, which gives us the resistance of the combination of resistors, needs to be first calculated here. So that is Rs is equal to R1 plus R2. So both R1 and R2 are equal to 2 ohms here. So this Rs will be equal to 4 ohms. The equivalent resistance in series will be equal to 4 ohms. Now let's see how we can calculate the heat produced in this combination of resistors. So as I mentioned before, again there is a mention of V, and there is a mention of the R resistance. So let's use the same formula. H is equal to V square by R into T. Here, because the combination is a series combination, instead of R in the formula I shall write RS. So H will be equal to, V value is same in the second circuit as well, so 12 square by RS we got it as 4 into T. So 12 square is 144 by 4 into T. If you simplify this, 144 by 4, it will be 36, and we're left with T. As we assumed before, we have to take the value of uh, T as 1. So let T is equal to 1 second. So H will be equal to 36 joules. So the heat produced in the second case is 36 joules. If you recall, the heat produced in the first case was 72 joules. Now let's see what's the third circuit. Let's see what is the third circuit, and we shall see how to calculate the heat produced in that circuit. So in the third case, or in the third circuit, there are two resistors, but as you can see, they are connected in parallel here. Now these two resistors are again connected to a 12 volt battery. So from the three circuits, it's evident that the potential difference of the battery is same, or the same battery is used in the three circuits. So we need to calculate the heat produced in the combination of these resistors. So let's first calculate RP here, that is equivalent resistance in parallel. Now because the two resistors are connected in parallel, let's calculate the equivalent resistance in parallel, or the total resistance in parallel. So I have told you this before in one of the videos. I shall repeat it. Here both the resistors are having the same resistance and they are connected in parallel, because both the resistors are having uh, equal resistance and they are connected in parallel. So we can use the formula Rp is equal to R by N. We can use the formula Rp is equal to R by N. So here Rp will be equal to, R is the resistance of both the resistors, that is 2, and N is the number of resistors. As you can see, there are two resistors connected here. So Rp is equal to 1 ohms. See, if you want, even you can use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2, or even we can use the formula Rp is equal to R1 R2 divided by R1 plus R2. So all these formulae are available in the list of formulae which I have made in one of the videos. Now let's continue to calculate the heat produced, in the combination of these resistors. So H is equal to, V square by R into T. Here we need to use Rp because the resistors are in parallel. Instead of R, I am writing Rp. So H is equal to, P value is 122, or rather I must say 12 square. It is 12 square. P square is 12 square divided by 1 into T. So this will be equal to 12 square by 1 is 144 by 1. It will be 144 in 144 144 T joules. 144 T joules. So T is equal to 1 second, as we assumed before in the previous two circuits. So H will be equal to 144 into 1. So it will be 144 joules. So this is the heat produced in case 3. So the heat produced in case 1, let's recall, let's summarize this, and then we can choose the correct option among the 4 given options. So the heat produced in case 1, where there was a single 2 ohm resistor, was 72 joules. The heat produced in the second case, in the circuit where there were two resistors in series is 36 joules. In the third circuit, that is the circuit which we looked into now, is 144 joules. Now let's go back to the question and see which is the correct option. So in the following circuit, so the same in all the cases, definitely if you can see option A is wrong, because the heat produced in the three cases are different. Minimum in case 1, 72 joules is not the minimum value, so therefore it's not the uh, correct one. Maximum in case 2, in fact 36 joules is the minimum of the three values, but here in option C there is a maximum in case 2, therefore option 2 is wrong. And the last case, maximum in case 3. So case 3, if you see, we have got 144 joules. So therefore it's maximum in case 3. 144 joules is the maximum value, that is maximum value of heat produced. So now therefore which option will be correct? We can choose option D, maximum in case 3. So the correct option is option D, maximum in case 3, maximum in parallel circuit. So thank you for watching. Please subscribe, like and share. Thank you again.